Welcome back to GCSE Physics Explained. I'm doing a revision session for Edexcel GCSE Combined Science Physics Paper 2 to help you answer the core practicals, 6-mark questions and other high-value questions. Feel free to pause the video at any point because I'll be going quite quickly so we can cover lots of content. Let's get started. Right, remember, every time you get an extra 4 marks, you're going to jump up a grade. I'm assuming that you can answer the 1-mark questions pretty easily yourself by now, the calculations pretty well after your revision, and I'm just going to focus on the core practicals, 6-mark questions, 5 marks, 4 marks, things like that. So, the 4 core practicals that could be on paper 2. Whenever you get a core practical or any questions with marks from 2 to 6, always base your explanation on a calculation, because the calculation will tell you what you need to measure. Then you just need to say what equipment you'll use to make those measurements and then add any extra details that you need to. So the first core practical is investigating resistance. So part 1, say how you would investigate the relationship between potential difference, current and resistance for a resistor or a filament lamp. 6 marks. So yeah, base your explanation on the calculation. The model answer would be resistance. We're trying to calculate the resistance. So resistance is potential difference over the current. So we need to measure the potential difference for your 2nd mark, say with a voltmeter for your 3rd mark, connected in parallel, measure the current with an ammeter connected in series. And that is how to get at least 6 marks. Now, depending on what the actual question is, you may need to change that slightly based on the context. So remember, if you're not agile, you're fragile. But what the calculation does is it gives you a very good basis for your answer that you may need to just tweak a bit. Right, part 2. Explain how you would test series and parallel circuits using resistors and filament lamps. 6 marks. The examiner is basically checking that you know how current and voltage behave in a series circuit and in a parallel circuit. So, how does current behave in a series circuit? Well, basically the current is the same everywhere, and to check that, we'd use ammeters connected in series, such as this. So you got 1 ammeter at the start and 1 ammeter at the end, and if this is 0.6 amps here, it should be 0.6 amps there. How does voltage behave in a series circuit? Well, basically tell the examiner the voltage is shared between the components, and you say use a voltmeters connected in parallel with the bulbs or with the resistors. And if this is 8 volts coming in, we would share that voltage between the components in the circuit. So if this resistor was the same as this resistor, then you'd have a 50-50 split of the original voltage, 4 volts and 4 volts. If this voltage was slightly more, it would mean that this resistor was slightly bigger than that resistor. I know this is showing you the bulbs, but each bulb's got a little bit of resistance. How does current behave in a parallel circuit? So tell the examiner the current is shared. So we're going to use ammeters again for 1 mark, connected in series. And as the current comes down here, it says 0.6 for example, gets to that junction there, and it's going to get shared. Some current's going to come across here and some current is going to come across here. If the resistance of this bulb is the same as the resistance of this bulb, then it'll be a 50-50 split of the original current. And it'll join back up over here to go back to the 0.6 amps, proving that the current was shared. How does voltage behave in a parallel circuit? Well, we use voltmeters connected in parallel to check that the voltage is the same in each branch. So that's how you'd get your 6 marks. They might ask you to draw a picture, or they might miss off these V's and A's and you'll have to pop them in. Now, whatever the voltage is of the supply, you'll have the same amount of voltage across this branch and the same amount of voltage across this branch. So 9 volts of the battery, you'll have 9 volts across here and 9 volts across here. it will give out a total of 18 volts, so that battery would go flat twice as quick. Core Practical 2. Investigating density. Investigate the densities of solids and liquids for 6 marks. Right, there's 2 types of solids that you're going to have to be able to get the density of. One of them is a regular shape, which basically means a shape with sort of flat edges that you can just measure the height, the width and the length with a ruler. So base your explanation on the calculation. What is the calculation for density? Density equals mass over volume, so you'll get 1 mark for quoting that. Then you'll say measure the mass with a balance, measure the volume with a ruler. What do you mean? Well, to get the volume, you do the height times by the width times by the length. And there is your 6 marks. As I say, that's a very good basis for the 6 marks. You may need to tweak it slightly on the day, depending on the context of the question. Right, what about the other solid? Well, this is an irregular shape, so it could be something like a stone or something with edges you can't measure with a ruler. In which case, we'll still start with the equation for density, mass over volume. This tells us we need to measure the mass. We can still get that with a balance. We'll need to measure the volume, but this time we'll have to use a displacement can. And basically, as you drop the object into the water, the amount of water that gets displaced equals the volume of the object. 6 marks. Thank you. Density of a liquid. Once again, it's density, so base your explanation on the calculation for density. So that's mass over volume, 1 mark for saying that. It tells us to measure the mass with what? With a balance. Measure the mass of the water. You will take the mass of the measuring cylinder and the water, like over here, and you'll take away the mass of just the measuring cylinder. So for example, put the measuring cylinder on the balance. It might say 50 grams, pop the water in, it goes up to 70 grams. So if we do 70, take away 50, we know that the mass of the water was 20 grams. We'd still need to measure the volume, and you'll get that with the measuring cylinder itself. So the good thing about this is as you pour the water into the measuring cylinder, you can literally get the volume from the measuring cylinder. Core Practical 3. Investigating water. Part 1. Investigate the properties of water by determining the specific heat capacity of water. So basically we need to find out how much energy it takes to heat 1 kilogram of substance up by 1 degree C, because that's the specific heat capacity. Right, once again, base your explanation on the calculation. So it's the calculation for specific heat capacity. That is energy divided by mass times by the temperature change. So we need to measure the energy with what? With a joule meter. We need to measure the mass with what? With a balance. We need to measure the temperature change with a thermometer. And to get the change in the temperature, you do the final temperature, take away the initial temperature. That should be enough for your 6 marks. If they ask slightly different questions and they say that the energy value is not correct, how could you correct that? You'll say put a lid on the top. They can sometimes say the specific heat capacity hasn't came out very well. What other reasons could that be? Well, it might be that you haven't measured the mass correctly, or you haven't measured the temperature correctly. So stir the water so that the thermometer is not sitting in a hot spot or a cold spot, and also make sure that the heater is fully submerged under the water, so you're not wasting the energy from the heater into the air. Part 2. Investigate the properties of water by obtaining a temperature time graph for melting ice. And use your knowledge of particle theory and kinetic theory to explain the sections is what they mean. So this is the equipment that we need. Get the ice crushed up into a test tube, pop a thermometer in there and heat it up. Now as you're heating it up, it obviously starts as ice, so it starts as a solid, so could be perhaps from -4. Now ice melts at 0, so once it gets to 0 degrees C, the temperature is going to stop going up as it changes state. That's what they want you to tell them. Then once it's changed state, the temperature will start going up as it's now a liquid. Make sure that you, if it asks you about the particle theory, you've got the solid particles are in nice, neat rows. It's got high density. These particles only vibrate. That would be kinetic theory. And then once it's a liquid, the particles are not in neat rows anymore. They're a little bit more spread out. Therefore, the density is less. And they can actually move if they're wanting to know some information about kinetic theory. Core Practical 3, Investigating Springs. Investigate the extension and work done when applying forces to a spring and calculate the spring constant. 6 marks. Right, obtain the spring constant. Once again, base your explanation on the calculation. This is what it looks like here. So the spring constant calculation, you're going to need to measure the force and the extension. So measure the length of the spring with a ruler. Put 1 Newton of force onto the spring, like the picture shows. Measure the new length of the spring. Right, now we'll be able to calculate the extension. So the extension is going to be the new length. Take away the original length. So just say the original length was 2 centimeters long, and when you've popped a 1 Newton of force on it, it's gone up to 4 centimeters. So the new length is 4. Take away the original length, 2, and that'll get you your extension. Then you just need to repeat steps 4 to 6, adding more force on until you've got 6 results. Why? To spot a pattern, and then plot the force against the extension on a graph, and the gradient will be the spring constant. And I can show you what that looks like in case that's how they want you to answer it, using this graph here. So force extension graph. When the force was 0, the extension was 0, so it'll always go through the origin. And as you add the force, it should extend linear, which means in a straight line. Don't exceed the elastic limit, otherwise you'll start going into a plastic distortion, which is a non-linear relationship. If they ask, is it directly proportional? You can identify that from a table. If you double the force, it should double the extension. 1 doubles to 2 and 2 doubles to 4. Let's check that again. Would 2 double to 4? Yep. And does 4 double to 8 at the same time? Yep. So this first section is definitely directly proportional. The spring constant is the gradient, because to get the gradient we do the y divided by the x, and that is force divided by extension, and that equals k. If they ask you about work done, that is the same as energy transferred, and energy transferred is a half times by the spring constant times by the extension squared, and that would basically be the area under the graph. How to answer other high value questions. So that's all the core practicals covered. But in my experience, and I've been teaching for 26 years, you could perhaps get a lot more high value questions. So let's have a look at these. Name the parts of a plug and say what they do. 6 marks. Right. You've got to say that this top wire is the earth wire. It's green and yellow. It's got a voltage of 0 and it's for safety. This left wire is the blue wire, and it takes the current away from the appliance. It's called the neutral wire because it's got a voltage of 0. How come its voltage is 0? Well, because this live wire is the one with the voltage, because this is the wire that brings the current in to the appliance and the voltage in. It's brown and it goes to the right. Now, because this has got all the voltage and the current in, the current needs to be checked before it goes into the appliance, and that is checked by the fuse. The fuse is for safety. And how does the fuse work? That could itself be a 6-mark question. Explain how a fuse works and state some disadvantages. So a fuse is a thin piece of wire inside the glass cartridge, and it's got metal connectors on either end. So tell the examiner that the fuse is a thin piece of wire. If a current higher than the fuse rating tries to pass through, so if 14 amps was try to go through a 13 amp fuse, the fuse would get hot, it melts or blows, don't say it blows up, it breaks the circuit by creating a gap, and that would turn the circuit off, which would stop electric shocks and fires. So you'll get your 6 marks for saying that. A disadvantage of the fuse is that it needs replacing once it has melted, and that would take longer to turn off the circuit compared to a circuit breaker, because it has to heat up and then it has to physically melt. Now we compare the fuse with a circuit breaker, which itself could be a 6-mark question, or 4 marks, or 3 marks, whatever. Explain how a circuit breaker works and state the advantages over a fuse. So a circuit breaker is an electromagnet. If a higher current than the rating tries to pass through, the electromagnet becomes stronger. It pulls on an iron contact. That creates a gap in the circuit, and it turns the circuit off, stopping the electric shocks and possibility of fires. Advantages: the circuit breaker can simply be reset rather than having to be replaced, so you just flick the switch back up. It turns the circuit off faster as well. It's more sensitive. It doesn't need to heat up like the fuse needed to before it broke the circuit. Explain how the national grid works for 6 marks. Right. Your model answer, once again, 7 marks possibly. You say a step-up transformer steps up the voltage. This makes the current small, so the transmission wires don't get hot, so electrical energy is not wasted as heat energy, which improves efficiency. Then we use a step-down transformer at the end to make the voltage small again. What does that look like in pictures? Right, we make 25,000 volts at the power station. Remember these values just in case that is the type of question you get on your paper this year. Now we use step-up transformers to step the voltage up 16 times from 25 kilovolts up to 400 kilovolts in the transmission lines. We make the voltage big so the current can be small and still have the same power. We want the current small, otherwise the wires will get hot and electrical energy will be wasted as heat energy. That's what we call line loss. Now, if we've stepped up the voltage at the beginning, we need to remember to step down the voltage at the end, because 400,000 volts is too much to put in people's houses and factories. We step the voltage down to 33 kilovolts for large factories, 11 kilovolts for small factories, and 230 volts for consumers like houses, schools, and hospitals. So loads of marks to be had there. Describe and explain current voltage graphs for a fixed resistor, bulb and a diode. Basically, you need to be familiar with these graphs here. The graph for a resistor is a straight line through the origin, directly proportional. Fixed resistor, so it has a fixed gradient. A filament lamp, or as I say to my students, a spulb, a bulb, It's an S-shape graph, okay? And finally, the other graph you need to know is for a diode, and that is a curve at the front here, and it's just a straight line at the back with no current. Because, of course, a diode lets no current flow in the reverse direction, but it does let current flow in the forward direction. You might also get asked how resistance changes with light intensity for a light-dependent resistor. You're going to get an exponential shaped graph. As the light intensity gets brighter, the resistance decreases. So this would be dim, that would be bright, and the resistance has got smaller. And it's exactly the same for a thermistor, which is a resistor that changes its resistance as the temperature changes. And once again, it's an exponential shape, and you can see as the temperature increases, the resistance decreases. And it's non-linear, just like that graph, because it's a curve. Describe the two types of current and explain how the electrons flow. Right, one type of current is alternating current. The alternating current comes from the mains for 1 mark. The typical voltage is 230 volts. And for your 3rd mark, the electrons flow backwards and forwards. 50 times per second if they ask. That's often a multiple choice question. The other type of current is direct current, DC. Direct current comes from batteries and cells for 1 mark. Typical voltage is 1.5 volts, and the electrons flow in one direction, not backwards and forwards like AC did. 6 marks. Thank you very much. Describe how you would carry out an experiment to determine the shape and direction of a magnetic field around a bar magnet. 6 marks. You must have done this at school with your teacher. For 6 marks, you basically place plotting compasses around the magnet, draw dots where the compass needle points. Connect the dots to see the shape, and draw arrows pointing from north to south to finish it off, just like the picture shows here. Describe how you would carry out an experiment to make an induced magnet. 6 marks. Model answer. Put 2 paper clips together to see that they don't attract at first. Place one of the paper clips on the magnet, just like that, and then bring the paper clips close again, just like that. Now they will attract. You have created an induced magnet. Then, to test that it is induced and not permanent, remove the paper clip from the magnet and they will no longer attract. So if you take that magnet away, all these paper clips should just drop away from each other, meaning that the magnetism is no longer there. Use particle model and kinetic theory to explain the temperature time graph. 6 marks. Right, so they may give you a graph like this. This is where it's solid, so we say using particle model, the particles are in neat rows, the forces are strong, the density is high. What about kinetic theory of a solid? The particles only vibrate. It has a change of state where it melts, then it turns into a liquid. Particle model for a liquid. The particles are further apart, the forces are weak, the density is lower, they're not in neat rows. Kinetic theory, how do they move? Well, they can move. That's all you need to say. Now, once the liquid evaporates or boils into a gas, the particles now get arranged like that. So the particle model, we say the particles are very spread out. There's no forces between the particles. The density is low. Kinetic theory, we say the particles move in a rapid and random motion. Higher only, explain the relationship between temperature and the pressure of a gas. Model answer, As the temperature increases, the average kinetic energy of the particles increase, so they move faster, they collide more often and with more force, so the pressure increases. So basically, as the temperature gets higher, the pressure gets bigger because these particles are smacking off the container walls more often and harder than when they were at a lower temperature. Higher only. Explain how transformers work. So a transformer is a piece of iron with a primary coil and a secondary coil. They only work with alternating current, not direct current. So that could be a question in itself. Model answer for 6 marks. Alternating current is put into the primary coil over here. That causes a continuously changing magnetic field in the primary coil. The iron core transfers this to the secondary coil. There's the iron core, which causes a changing potential difference in the secondary coil. The potential difference in the secondary coil is greater if it has more turns than the primary coil. That's what we call a step-up transformer. So you can see here, the primary coil only has 5 turns, whereas the secondary coil has 10 turns. Notice the ratio. 5 turns to 10 turns is 1 to 2. So for every 1 volt you put in, you're getting 2 volts out. So in other words, the turns doubled, so the voltage will double as well. Remember, you can get marks for calculations for transformers. The power in to the primary must equal the power out of the primary. Remember, power is current times by voltage, so the current times by the voltage that goes in must equal the current times by the voltage that comes out. That's how in a step-up transformer we make the voltage 16 times bigger, which means that the current had to be 16 times smaller to make sure the same power came out that went in. You can't just make power out of thin air. If you're the triple only, you might get asked about the voltages and the turns. So the voltage on the primary divided by the voltage on the secondary is going to equal the number of turns on the primary divided by the number of turns on the secondary. 10 volts divided by 20 volts is a half. 5 turns divided by 10 turns is a half. So the ratio of the voltages is the same as the ratio of the number of turns. Triple only. Explain what causes the pressure of a gas and how volume affects pressure. So not temperature, volume. Right, so basically if you've got a gas like that and then you suddenly squash it down into a smaller box, it's going to be hitting off the container walls more often. Watch this. So the particles collide into each other and into the container walls. They put a force on the walls that causes pressure. For a fixed mass of gas, decreasing the volume will increase the pressure because there's going to be more collisions per second, as I've just said. Other content you might get asked about. Draw the shape of magnetic fields. So a bar magnet looks like a butterfly pattern like that. You need to say the magnetic field comes out of the North Pole and goes into the South Pole. Magnetic field comes out of the North, comes round, goes into the South. 1 mark. Magnetic field is the strongest at the poles. Sometimes I say put across where the magnetic field is the strongest. It's the strongest here and here. How do we know? Well, because the magnetic fields are the closest together at those points. 3 marks. What if it says draw a uniform magnetic field? So if you've got 2 flat magnets like this, the magnetic field once again comes out of the North Pole and goes into the South Pole. So make sure you draw arrows going from the north to the south. You need to draw at least 3 parallel lines. 1, 2, 3. And make sure that they are equally spaced apart. Force extension graphs. What do you need to know? You need to know that a spring goes straight at first, then goes curvy once the elastic limit is exceeded. You need to know that a rubber band comes up and curls like that. The bigger the force, the bigger the extension, and it's non-linear because it's a curve. So actually at first it's linear for the spring, then it becomes non-linear. The rubber band is non-linear from the start. Graph A shows the force and extension for 2 different springs. Spring X needs a bigger force than spring Y to produce the same extension. So that means that spring X is stiffer. It's got a steeper slope compared to spring Y. Let's look at spring X. To make spring X extend by 0.5, we had to put on 50 newtons, whereas spring Y had the same extension, 0.5, and we only needed to put 20 newtons on. So the steeper the line is, it means the stiffer the spring. How do we explain it? Generally, the bigger the force, the bigger the extension, and this time for your second mark, you see it's linear because they are straight lines. And that'll do you. Bit of a crash course there. Very, very best of luck. Right, from me, Mr. Obi, GCSE Physics Explained. You've got your exam on Monday. And if I don't get to talk to my students after the exam, very best of luck. I look forward to seeing your exam results in August, you lovely, lovely people. And good luck with whatever you choose to do in the next part of your life.